I'm going to introduce your introduction about SIG scheduling, and I'm Klaus, and this is my GitHub ID, Twitter ID, and also Slack ID. You can ping me on in the internet, and this is my email, personal email from Huawei. So from the SIG scheduling, I think this is our chart of our responsibility of SIG scheduling. And I highlight in red is that our major responsibility is to is a pod placement decision. So in the cluster, we are going to have several pending pod and have some idle node here. We are trying to find some way to have a better decision to put this pending pod on the node. And there is another topic is about resource plan, such as a quota, how many resources for tenants should be used, and whether they can share resources between different tenants. For this topic about resource plan, this is for now this is not it's out of scope of SIG scheduling. It's belong to the API machine learning. There are lots of history about this part, but you can ping us on the night, and we would like to also have some involved in this discussion right now. Anyway, this is the official chart of SIG scheduling, but we also have some other related activity in the community part. Yeah, and if you want to connect us or propose some idea or propose something in the SIG scheduling, there is some way to ping us. Now the first one is we have a weekly meeting here. This meeting is 1 by 1. So one meeting is Europe and US friendly, and the other one is Asia friendly. So so you can find the meeting. You can find a better meeting for your time zone. Another one is we have two leaders here, and Bobby from Google, and the other one is me from Huawei right now. And we also have Slack and mail list, and you can find some issue about SIG scheduling. This is the major ways you can find us in the community part. In the from SIG scheduling, at the beginning of SIG scheduling, we focus on the kube-scheduler. This is we call it a kube-scheduler, default scheduler. All kind of thing is we are talking about is a kube-scheduler. This is our major sub project of this SIG. Our major feature are implemented in this sub project, and this sub project is in the upstream. And but since last year, or maybe the year before last year, we find more and more workload would like to run in Kubernetes. Now the first one, I think the famous one will be Kubeflow. There are lots of topic in KubeCon recently. So it's a machine learning related workload. Another one is the big data part, Spark. Right. There also have some requirement from traditional HPC user. This logo is OpenMPI. They also would like to run the workload in Kubernetes. So we need to support such kind of high performance workload or batch workload in Kubernetes. So we some feature is such kind of gun scheduling, fair share between the job and queue, something like a concept in Kubernetes. But because of complex, we incubate another project. We call it kube-batch. So kube-batch is a batch scheduler focused on high performance workload, belong to the SIG scheduling part. And we also find some, and also some people propose another project, Poseidon, because they have some paper, they have some way to get a better throughput to place the pod based on the graph, mean cost of flow for this part. So there is another project or another way to place the pod in the cluster. There is also another sub project, Descheduler, because when when the pod come and run, the some restrict some pod affinity or anti-affinity maybe not true. So we need to another component to create that one. So I will introduce the one by one of this of those projects and to see how they work together. Yeah. Now the first one is kube-scheduler. Now kube-scheduler in the default, this is the default scheduler of Kubernetes, and in the scheduler it have a queue, and it will handle the pod one by one. Yes, from every time it will pop up one pod and to find a host in the cluster. When it finds the code in the cluster, it will do two major phases. Now the first one is we call it predicts. Predicts means some node cannot fit pod's requirement, such as we want to run some pod on some special node. Yes, such as node selector, node affinity, something like that. So in this part, it will only identify, for example, in this picture, node 1 and node n are not, we cannot schedule a pod to the node 1 and node n. And node 2, 3, 4 are available candidates for this pod. So the second phase is how to choose a better one for the node. So we will have several policy to give a score for the node. So for the node 3, we think node 3 is better based on several policy here. We have 90 score here. So we are going to dispatch this pod to the node 3. Right. This is the major phase of this of default scheduler. Yeah. Another one is kube-batch here. Kube-batch focuses on the batch scheduling and maybe some resource sharing between the different tenants. And his top priority is batch scheduling. Resource sharing between tenants is a really big story in the Kubernetes. So I think this is a really low priority for now. kube-batch right now is a kube-scheduler, but there are also some other enhancement across the Kubernetes. Now, such as data management, such as data locality, and preload and something else, and some isolation in the node. And we are going to have some new container runtime for example, Singularity for HPC. And we also need to have job management. Job management, it means, for example, multiple pod template in a job, right? For machine learning job, for example, for TF job, they have a PS, they have worker, they have different pod template. But for the job in the core part, it's only support one pod template. That means every pod is all the pod use the same image here. Yeah. And we also need to support some accelerators such as GPU, FPGA, something like some new hardware here. We are going to propose some other project to include all of these things. But for kube-batch, it's only a scheduler. Only consider the batch scheduling part. Yeah. This is the overview in the kube-batch. It will dump everything or every pod and info into the kube-batch. So here is so you can see everyone will dump into the cache, and there will do several action here. The action is predicts, allocate, and preemption, maybe some backfill here later. And the action is configurable. You can change the order. You can disable someone. For example, if you don't need to preempt, you can just enable predicts and allocate. It will make sure you there no pod will be evicted. And there also have some plugin here, so you can choose which plugin you are going to use. This is the major feature of kube-batch right now. And the blue one is we are going to we already have an agreement in the upstream, yes, such as called scheduling. It's similar to GAN scheduling because we have some rename early of this year. Yeah, we also have code scheduling is we have design document in the upstream, and we are going to migrate this feature from kube-batch to the default scheduler. There also have some other features for the batch. Yeah, and the second one is the fair sharing between the job and between the queue. We have fair sharing means, for example, I only want to use half cluster resource in this cluster, and the other half resource will share to the other job. In the default scheduler, we cannot do that, right? They schedule pod one by one, and they don't have concept of job and how to share between the different. For example, if you start two deployment, if each deployment have enough pod, in the worst case, one deployment will consume all resources in the cluster, right? And the second one, you need to give a high priority, around to preempt the other one. And if the second one also have enough resources, it will preempt all the things of the first one. So the fair share means they can share the resource between the different jobs in the cluster. So the other one is the preemption. Yeah, this is the same work together with the fair share to share resources between to share a cluster between the jobs. And there are also some task about task priority within a job, because some tasks within a job have dependency, such as the Spark driver and the Spark executor. We need to make sure the resource always give driver instead of executor. At currently, as the Spark and on Kubernetes it will start a driver and then the driver to start executor to resolve such kind of dependency problem. I think it can be enhanced with in the scheduler part. Yes, it also support predicts similar to the default scheduler. It just import the IRE predicts into the kube-batch right now. It also supports queue, backfill, and dynamic configuration. All this feature is, I think this is in the experimental level. So you can try this one and give us feedback. We will keep enhancement that. And the issue is that I didn't propose the detail to the upstream, so the API may be changed, and maybe the behavior may be changed. So you can try this one, and I will summarize the feedback and propose the detail to the upstream, so we can migrate this feature one by one to the upstream. Yeah. I also open another issue to the in the upstream. That's mean bring batch capability into Kubernetes. So everything in the previous page, include job management, data management, everything's here. It will include this issue. I will do this one by one, and if anyone want to contribute, you can check this one, and I will summarize more things here open here. Yeah. The other sub project is Poseidon. Poseidon is they try to integrate with the Firmament into Kubernetes. Firmament is another scheduler. It try to do the scheduling in a different way. It will have a graph. So each edge will have a cost. So it will find the minimal cost flow in in this graph of the whole cluster. Poseidon gave a adapter from the Kubernetes to the Firmament. So in the Firmament, Firmament is another community you can check in the internet. Yeah. for the firmament and for the Poseidon, they in the Google group, there we have a test here is that they have a better throughput in some scenario to the compared to the default scheduler. We did. I'm not sure anyone tested this in the production environment, so we just have some test here. We get in some scenario, so you can have a try and to find if they can work better than the default scheduler. Yeah. Another one is a default Poseidon didn't support every feature in the compared to the default scheduler. It supports just some predicts such as node level affinity and pod level affinity, and tent and toleration. In default scheduler, there are several predicts here, and and it will keep including, yes. And it also supports such kind of gun scheduling. This is also a major for the batch workload to make it better. Yeah. We have several schedulers here, and some people always ask how those schedulers work together. Yes, we have kube-batch, we have default scheduler, and we have Poseidon. I think my answer is I don't know. Right, I don't know. Yes, but we do have some option or proposed here. Because I don't know, because only the default scheduler is production ready. The other two scheduler is an incubator project. Now the first one is kube-batch, the other is Poseidon. So we don't have a chance to consider how they work together. Yes, because the other one is an incubator project. Our focus on to make get enough feature and make it stable. So we are going to consider how these two scheduler will going to work together. But we have some option here. The first one is different scheduler on different node. So for example, if you have a pod, you just submit a pod to the scheduler 1 or to scheduler 2. So there will be no resource conflict, no decision conflict here. But the problem is that if node 1 or node 2 is idle, the scheduler 2 cannot use 1. So some resource will be, the resource utilization may be not well, yeah, not good enough. Yeah. The second one is the default implementation of multi-scheduler, how we resolve the decision conflict. Yes, so for the option 2, scheduler 1 and scheduler 2 can see all the nodes in the cluster. But the problem is that if scheduler 2 make a decision, and scheduler 1 is also make the same scheduling decision, they will have conflict. So the kubelet will reject the later one. Yeah, in the for the long running service or for the service workload, I think that's fine because for a service they're going to run really a long time. For example, 1 day or 2 days. So reschedule is acceptable, right? But for the batch workload, that will be a challenge to the SRE. For example, for the default scheduler, for a batch workload, they're going to be run just 1 or 2 minutes, and you keep reschedule it. This will be really a challenge to the SRE. Another big issue is that for the gun scheduling, they need to, for example, for MPI workload, they need to all pods to start together. If one decision was rejected, the whole job needed to reschedule together. That will be really challenge to the batch scheduler. Really challenge to the back workload. I think yeah. The other two option is there have some proposal to the option 3 is that we have a bootstrapped similar to the two-level scheduling. Such kind of component will have the whole wheel of the node, and for example, he will make the decision which scheduler are going to use which node or which part of node cluster. But this is also have some issue here is that pod have several requirements to the node. For example, node affinity, scatter, pod affinity, something, all these things. So the bootstrap may not make a good decision to the scheduler, right? So otherwise, you need to know everything here. So I think the option 3 may be just an option here, but I don't think that we are going to do in this direction. The other option, the option 4, is that we would like to combine everything in one scheduler. Yes, this is what we are going. I think this is what we are going to do here because of the effort and the timeline. In the option 4 is that we are going to migrate feature one by one to the default scheduler, right? Default scheduler also has some enhancement to the for the pluggable. For example, we are going to have a scheduling framework, so you can implement something or some plugin to the default scheduler to make it extendable. I think the biggest challenge for us is that the default scheduler didn't have job concept right now. So we are going, if we want to support batch workload, support job scheduling such as a fair share between the different jobs, we are going to introduce some job concept in the default scheduler. And we are going to implement some queue or something in the default scheduler to support that. There's going to be a challenge for us, but at least for now, we are going to, in this direction, try to merge this feature, migrate this feature one by one to the default scheduler, and keep enhancing the scheduling framework to support different kind of workload. Yeah. The other one is a Descheduler. Descheduler it's used to be called a rescheduler. This is just a small component for the in the upstream. But we think that feature is really useful to all scheduler. So we rename it to Descheduler and separate it as an incubator project here. Here is some user case of Descheduler. Now the first one, I think this is try to balance the workload in the node, because for the scheduler, it only can make the decision when the pod is pending. When nodes are running, it's just ignore the running pod here. It didn't care or didn't reschedule the running pod. So it needs another separate component to trigger such kind of rescheduling. So here, this is the major target of the major responsibility of the Descheduler. The second one is some scheduling decision may be not true anymore. I think one example is that pod affinity. For example, pod A want to run together with pod B, so they set a pod affinity, and they schedule to the same pod right now. But unfortunately, the pod B is killed by some others. But the pod A didn't know that, and the default scheduler will not reschedule the pod A because pod A is running. It thinks everyone is good. So in this case, it needs to descheduler to shut to evict pod A and to rerun the scheduling logic to have a better decision for this one. The other point is node is failed and something is moved to the other node. Yes, the pod on one node is killed, so the pod is evicted and rescheduled to the other node. And when this node is back, default scheduler will not do that, move this pod to the restarted kubelet. This will be in some cases will that when you keep upgrading the node, every pod will move to some small to the node in a small group. Yes, this part of group will have a really high workload, and the other one is idle. So if you, after several times, after upgrade, you run Descheduler, you will have to move this pod to the idle hold, to the idle node. Yeah. So this is some policy and some strategy for the Descheduler to do. Now, the first one is remove duplicate, and the second one is low node utilization. That means if some node is have low priority, low utilization, it will try to move pod from the other node to here. And the other one is try to correct the validation of pod of entity and pod entity of entity and pod of, and node of entity. Yes, for the node of entity is that node of entity will similar to the node selector. It will use some label to find to make sure one pod scheduled to the to some node. But when the node label is updated or changed, the default scheduler didn't know that. It's hard for it to reschedule the pod. So Descheduler will do that. But the Descheduler will not will have some restriction to evict the pod. Now the first one is a create pod. It will not care about the create pod. I think this restriction will be removed later because critical pod will be replaced by the priority and preemption. I think this will be critical pod feature will be removed in 1 or 2 release. So for this part, I think this is just just to keep backward compatibility with that. The other one is a pod is not part of RC. That means some mirror pod and some standalone pod. Because for Descheduler, when it depends on the controller to recreate the pod, right? For RC, for RS, it will recreate. If pod is killed, the controller will recreate it. But for some standalone or static or mirror pod, no one to create this one. So if Descheduler evict or kill, I don't think this we need to call it kill. It should be delete. We don't have kill in the Kubernetes right now. For the delete, the pod is gone, right? No one can recreate the pod. Yeah. So for Descheduler, it's only care about who have a owner here, some controller here. Yeah. And the other one is daemon site. Daemon site will start a pod on each node, right? So the Descheduler will not to try to evict the daemon site pod because it will reschedule the pod on this node. This nothing would change, so it didn't need to evict that. The other one is local storage because it needs to use the local storage here. So it will. I think the controller will also reschedule the pod to this node. When it start up. The other one is some best alpha pod will be killed firstly because it didn't by default is a really low priority to the system. Yeah, and it will never evict pod if it break a PDB pod disrupted budget. Yeah, because it makes sure the service will be stable here. Yeah. I think this is overall of my introduce about the scheduling. Go through the each sub project here, and we are going to have a deep dive about our scheduling SIG. I think it is tomorrow. Yeah. So Bobby will give a deep dive about our SIG, and you can join this session for this one for more details about default scheduler. Yeah. Okay. Thank you. This all from me. Yeah. Okay. Any question? Okay, sure.
Yeah. So Domo, I wrote for Domo to be open source to a project called kube-batch that we use to kind of augment the scheduler.
Mm-hmm.
My question is should I work, it's a kind of thing where I thought it's useful enough that I'd like to work with the team to see if it fits somewhere into upstream Kubernetes, because I think it's a useful concept.
Mm-hmm.
Should I like go on the Slack channel and introduce it? What's the best way to like say, I've got this really cool scheduling thing, where does it fit upstream?
For this thing, I think I'd like to maybe you. I think you can open an issue here, describe the user scenario and what's the problem we are going to resolve. And we are going to have whether this should be a project, for example, to the default scheduler or to some other project, or whether we should start another sub-project to for this scenario.
Okay.
Yeah. Okay.
Yeah, so I'm from JD.com, so we are running a very large number of applications of diverse workloads and massive scale. One of the largest cluster is about 10,000 physical servers. So I'm wondering if the scalability of the scheduler also given the function services workloads, right? We have to schedule it much more dynamically faster. So my question here is the scalability of the scheduler is something that you guys are working on or consider, particularly given that all the scheduler cases make decisions, I think the scalability.
Okay. I think the question is about the scalability and about the default scheduler. I know several people from JD.com ask a similar question in China. Yeah, I think scalability and scalability is a major, and the performance is a major. I think this is a major effort in the next year for the default scheduler. Bobby did several things to enhance the performance of default scheduler. Yeah.
Yeah. To me, it's about the schedule throughput, right? Because we have a lot of new workloads, right? Traditional schedule is no running one is okay. Take several seconds, minutes to make a decision. Now the function service request you have to make a much bigger decision. Otherwise, the scale, right, increased. Like now we will see this kind of this very large scale deployment. Like we have this 10,000 server. Containers. You have to make the quick decision. Right?
Yeah.
Schedule throughput.
Yeah. I think you can if there. I know JD.com have some similar about the throughput because I get several feedback about this one. I think if we can share some log, some workload pattern here, that will be help Bobby to or help us to identify where is the key point for right now. For currently or for our work right now is try to identify where is the bottleneck to the default scheduler. This different workload maybe trigger different paths about the bottleneck. So we need to know where is the bottleneck for the requirement. Yeah.
How could we contribute? So what's your recommendation?
If you can share maybe some workload pattern here, and if you already identify some bottleneck in the Kubernetes, you can open an issue to or open a pull request here in the upstream.
Okay.
Yeah. Okay. Good.
I always get asked about first in, first out scheduling. The kind of work we do, we have a lot of jobs that come in, and we schedule a lot of pods that are kind of started in an order. The scheduler right now is the best effort, right? If it can't schedule a pod, it goes to the next pod. Because sometimes a pod doesn't fit right now and it'll fit later. Is there any plan or how, I'm asked almost every week, like how can we make the scheduler prioritize the first pod in to be the next pod scheduled and not to do anything else? Is that, I know that's not, it's kind of contrary to what Kubernetes does. Like, I know that's not normally what the scheduler does, right? But is there a tool, does anybody know how to do guaranteed? Right.
What are you trying to do? Evict the others, or are you trying to say, I don't want to schedule pod 2 until 1 is done?
I don't want to. Yeah, I'm saying I don't want to schedule pod 2 until
Even if
1
there's
is
capacity, it just sits there.
Yeah.
So isn't that affinity in a way?
It's not though. I mean, you can't really do it with affinity, right? So I just, if I've got a user clicking a button that's generating pods to do it work, I don't want the first thing that got sent to the cluster to, the cluster's out of capacity, so the first thing doesn't run. And then later there's capacity, but it's the other things that are, there are other things that come in behind it and fill up the space.
Yeah.
You just set priorities.
Is there a priority feature?
Yeah, from my point, I think we have a priority. Make sure high priority will always run firstly. Yeah, and if you enable the preemption, the high priority will preempt the low priority. Yes.
Where you can say 2 depends on 1, so first 1, and when 1 is out, you do 2. Because you can't place 1, but you can't place 2, then even with priorities, it's not helping.
We don't have pod dependency right now. It's dependent on the operator to do that. And as far as I know, some workflow operator do similar thing is that when one pod is finished, they start the other one. Yes, there's a pod. I'm not sure your case is for workflow or just someone have a high priority to use the cluster resource.
I think you've got some good ideas. So.
Okay. Okay.
Are the concepts you described on the Descheduler interact with kube-scheduler, kube-batch and Predicate? You mentioned some things regarding everything pods. I wonder how this will play in combination with having, let's say, the horizontal scheduler. Aren't these two interact with each other?
Sorry, I didn't get your point. Get your question.
So you mentioned the Descheduler.
Descheduler.
Yes.
Yeah.
You described that you could evict pods, for example, right? Based on what the review is happening.
Mm-hmm.
Okay, and there are some other projects in Kubernetes about, autoscaler and horizontal scaler that their decisions could also interact with the decisions you take as a scheduler. Is that correct?
Oh, Descheduler only triggers the eviction. It just kill the pod.
Right.
Yeah, yes, and the controller will create the pod, and it goes through the scheduler to make the second decision. Yeah, it's make a pod reschedule. Yeah.
I think the question is about resizing pods, right?
Yeah.
There's these other projects that they are trying basically to resize a pod or create new pods or shrink things based on the load.
Oh.
So how this interacts with
This
schedule.
for the shrink or auto-scaling part, this is not covered in the descheduler part. It's
The problem which this scheduler tries to solve is the fragmentation of this.
Okay, just they don't seem to me like being vertical. It seems to me
Yeah.
like probably they will interact with each other. Like the one affects the decisions of the scheduler, affects the decisions that the other scheduler will take.
Okay.
I'm not sure this is really the question is it in this form? I want to ask about disconnected behaviors of the kubelet when the kubelet loses connection to the rest of the cluster, and after a while you can set some behaviors in the scheduler saying after a minute, 5 minutes, half an hour where I haven't heard from this kubelet, I can reschedule the pods. But where do we talk about the behavior on the disconnected node? I want to say that if he loses connection, this critical service must be stopped. And right now the kubelet does not do these kind of jobs. I don't know if it's part of SIG Scheduler because it kind of sounds like the kubelet auto-killing its pods, or is it a separate special interest group?
There are several components may contribute this part. Now the first one may be node life cycle controller.
Okay.
Yes, it will have if some node is unschedulable or unreachable, it will give a 10 to the node object. This object is still in the API server.
The
Yeah.
type controller runs on the node?
No. It updates the state in the.
Segmentation
I'm talking
between
about
the
split brain, yes.
kubelet and so the Kubernetes cluster will delete the pod after a certain
Yeah.
amount of time. But
Yeah.
the kubelet may still be running your workload and it's
Mhm.
doing like it's a rogue agent at that point.
Exactly.
And so you want the inverse. You want the kubelet to respect the kind of like
I want to be able to tag my pods to say if the kubelet gets disconnected, goes rogue,
Right.
then shut down.
which
Because-
seems like it's the same thing. Like pods already have they have tolerations for the no executing. Right? That's the way like the scheduler, not the controller manager decides when to delete a pod is based on. Right now it's based on like the amount of time you tolerate a no executing on the node you're on. But that's all in the you're right. It's all still in the cluster. None of that is in the kubelet. So you kind of want that same data to be read by the kubelet
Yes.
and have it. I don't know. I don't think that's scheduling. I think that's like.
Is this
that-
another
the
interest
kubelet.
group that we've discussed this then?
Yeah, I bet you that's SIG. Is there SIG kubelet?
Signal?
Oh, SIG no. Yeah.
Yes, signal.
Okay.
Yeah.
It's a really good idea because you don't want a rogue agent like just the
No,
cluster.
no, we have
build, it
some
doesn't mean
customers
it's
that
off.
really don't want that. NFS shares, anything shared that could be, you could be split brand, but still have data.
Yeah. I can see that in the problem.
Okay, that's all. Okay, thank you.